a few more important concepts left. I tried to cover those two. The first one, D.1, virtual tables. Virtual, not physical tables. So far, we talk about physical tables. Now, virtual tables. So let me describe them. Why we need virtual tables. All right. View of a database. Here, we have a new concept called a view concept. All right. So this view is different from our regular view. Right? In our database, this view has its specific meaning. So when you read technical documents, you need to look at the context. So if it's in a database concept, if it's in a database context, then when you see this view, you need to connect to this virtual table concept. So let me describe this virtual table concept first. All right. Okay. Why we need it first? Let me describe the situation, a typical situation. So different users may require different perspectives on the same set of data. So that's the general information. So when we store our original data, we try to reduce redundancy. All right. Although we know we cannot completely remove redundancy. But we try to control our redundancy. Okay. But in that case, different users, based on their business needs, they like to view different parts of the data. And they like to view, sometimes derive the data. So not your original data directly. In some way, combine the data from different tables. They like to view in that way. That's quite normal, right? So you need to run certain database queries to generate the required data for your users. Okay, all right. So here, the thing is, after you generate the data, most of the time, you don't want to derive the data, right? It's not necessary. It's not necessary to store the derived data. So here, the situation. In general, not necessary to store the derived data. Okay, So here we can assume derived data relies on a sequence of queries. Okay, rely on sequence of queries, derived data. Okay, most of the time, we don't want to store derived data, but sometimes, sometimes we want to store. All right, let's say 90% of the time, we do not store it. Okay, 10% of the time need to store it. Okay, just get an idea. All right. So here the issue is how to access these 90% of derived data efficiently. Efficient way handling the data. Access. We want to access it in an efficient way. Yeah. Because next time, these perspectives, our users may need to access them repeatedly. Think about that. Access it repeatedly. Think about that. We do not need to store that data. We want to save our storage space. But at the same time, we need to access those perspectives repeatedly and efficiently. Think about that situation, that kind of requirements. Okay, yeah. Here, the solution using views, using virtual tables. Views, virtual tables. Okay, yeah. So I will describe this concept. Yeah. Virtual data. Yeah. We don't want to store this part of the data physically. Okay, on our hard drive, we won't store this generated data on our hard drive. Okay, yeah. No physical storage. We want to save, as much as we can. But for this 10%, because we treat this 10% extremely important, so we want to store this 10%. We are willing to use some extra storage space to store this small portion physically, derive the data physically. Okay, yeah. All right, so derived from physical data. That means if we, due to some reason, we lose this part of data, we can recover easily, right? We just run the same sequence of queries another time, we recover it easily. Okay, yeah, derived data, not original data. Original data, if we lose the original data, we cannot recover, right? So you have to pay, because to acquire that part of data, you need to spend a lot of money, in your business. To recover that part of data, you need to pay a lot to get it back. Yeah. But for this derived data, we just run the same sequence of queries. Now we can get that part back. Yeah. Save storage space. Yeah. Could be stored physically if needed. So yeah, that's this 10% case. Yeah. Only we have good reasons. We have good reasons. Oh, we really need to store this part, this small portion data physically. Yeah, because so important. Even if the original data is missing or changed, we like to keep that part of data. Yeah, because your derived data rely on original data. Okay, when your original data changes, your derived data also changes, right? Yeah, that's normal. Yeah, so we need to be aware of it. Okay, oh, yeah. But we know the concept state, right? State concept. Yeah. So at each time instance, your data has that state, particular state. Okay. When the time instance changes, your state of your data could change. But you may like to store old state data, right? Think about old state, yeah. Because in my business needs, I need to store certain business data in maintaining a few old instances. In that case, you need to store the physical data. Okay, the data, the derived data physically. Derived data physically. Okay, all right. Yeah. All right, yeah. So now, before I complete it, let me summarize this idea. So this virtual table idea. Here I describe the situation we needed. Yeah. So here, let me summarize the view. That is the virtual table. This idea. Okay, yeah. So you think about how to define a table, physical table. We know how to define a table, right? Yeah, because we use create table statement, SQL statement, create table statement. All right. Remaining, yeah. So you know the details. Yeah. Here, now we get to how to define a virtual table. We call it view. Right? The same way as you define a table, but you change table to view. That's the only change. Create view. Remaining the same as your table way. Then the DBMS will treat it as a virtual table. And you store the data, yeah, because when you run queries, you have a table view, right? You have a table view. You can see the data in a table way, all right? But that table way, that's the view. That part of data won't be stored physically. No extra storage space is used for that part of the data, although you can see it. Yeah. But that's the generated data. Okay, yeah. So because you have this statement for the view, every time you need to access this virtual table, the DBMS executed this view another time, so you can see the data. That's the way. Every time this same query needs to be executed, the same query needs to be executed, this view needs to be executed. Yeah. Okay, yeah. All right. Yeah, later we will see some examples. Yeah. Today we just learned this abstract concept. All right. Next, size of a database. Yeah. When we use databases, we may like to get an idea. Do we have any limitation for a typical database? Yeah. So here the answer is this, very simple. The general case. Yeah. A database can be of any size and a complexity. No limit, no specific limit on the database size. Several gigabytes, yeah, no such limit. Yeah. In SQL, there is no such limit. Okay, but in our actual resources, yeah, nobody has unlimited resources, right? Yeah. So there is a actual limit in your resource. That's your resource limit, right? That's your resource limit, but that's not the database limit. Okay, yeah. All right. DBMS may have a restriction for the special cases. Yeah, here. Yeah. Let me use these simple examples. For MySQL, Oracle, no limit. Yeah, because they, these two powerful DBMS used in industry. Okay, no limit. But we know Microsoft Access, that's for small business, or even the personal, home business even. That's the main target of the Microsoft Access, home business. Even, if your business a little larger, you may like to choose more powerful DBMS. And the Microsoft Access put this 2 gigabytes limit. 2 gigabytes limit. Okay? Yeah. If you reach the limit, then you can save your older data in, hard drive, hard disk, somewhere, right? Back up your old data, right? Yeah. But you may not need to use your older data in the previous many years. You can back up your older data. Then you only maintain your data for recent years. So you can control your data within the limit. If you have a very small business and you use the Microsoft Access to store your business data, you need to manage your data carefully. For MySQL, don't worry, all your business data. But your hard disk, your hard drive probably has some limit, right? Yeah, it may run, used up your hard drive space. You need to back up your old data, right? Yeah. All right. So that's the size of a database. Understanding query. So here, we frequently use the query. This is, a very common word we need to use in our database class. But what's the exact meaning of query? Typically, there are 2 different meanings. The first one, in narrow sense. So that's the data retrieval. Refers to data retrieval. Yeah. And the data retrieval, that's the read operation. Read only. Okay. We do not change the data. We just read the data. Retrieval, yeah. That's the narrow sense, original narrow sense for query. But there is another broader sense. Because people, many times they take this broader sense. That's any database access, including modifying data, we call query. Any operation on data, we can use query to refer to it. Okay, so that's the broader sense. So when you read database text, sometimes you may have the first meaning, sometimes you may have the second meaning. Okay, yeah. All right. Next, I like to give you a little more information on stored procedures. So last time, when we learned advanced features, so I talk about that. So today, so let me give you a little more information. Yeah. I like to give you some examples, but I look at my examples a little early. Okay. Yeah. So we need to get familiar with our databases more, then I can talk about those examples. Yeah. Procedure examples, store procedure examples. Yeah. All right. So today is still high level knowledge part, situations. Yeah. All right. Yeah. Some of the points I already discussed before. So for that part, I may go a little fast. Resources are distributed on different machines. Yeah. Think about, we have a large system. So here, we have a large system. System here, we mean, some business system running our business, So this system actually, we mean web application. Okay, a web application, that system, okay, business system, okay, running our business. But it is very large. Okay, yeah, worldwide. Think about the worldwide business. Yeah. So we need to use many servers distributed in the world to run this one big system. Think about that situation. Okay, all right. The web application programs are on a web server. Yeah, here, let's imagine we have many servers in the world. Yeah. Let's say server 1, server 2, server 3, and so on. Okay, yeah. But all these servers work together as one system. Okay, yeah. All right. And the code, typically the code on different servers should be different. Yeah. All right. But they work closely, they work together. So, a lot of communications are needed between those servers. A lot of inter-server communications needed. Yeah. All right. So that situation. DBMS is running on a database server. Some of the servers are used as database servers. Some other servers are used as web servers. So they work together. Okay, all right. An efficient way, database program modules. Here, think about, we want to manipulate our data for some specific purpose, data processing purpose. All right. And that, so here, suppose there is some algorithm for data processing. Okay, some algorithm. And we know, suppose this is critical for business. Okay, this algorithm is critical for business. Okay, yeah. So it is used frequently, critical for business. Okay, yeah, some very important data processing algorithm. Yeah. Think about that. All right. Then we want to have some efficient way to run this algorithm. Yeah. For some database program modules. Not one, yeah, some algorithms, all right? Yeah. Several algorithms, very critical for our business. Okay, yeah. We need to frequently run those special algorithms to generate our business data. Okay, yeah. So here, let's talk about efficient way. Okay, all right. All right, so here, let me describe the stored procedures two format. This efficient way, later I will come back, okay? Later I will come back to talk about this efficient way. First, in SQL, we define a construct, okay? So here, SQL construct. It's called a procedure. Procedures, when you use procedures, no explicit output. Yeah. So it's a function, but this function, no output, just like we use void, right? When we write define function methods, we can declare this function does not generate output. So the void type. Yeah. So this procedure corresponds to the void type functions. It only does the data processing, but it does not return output of the data. Sometimes we use that, right? But we need to generate the data. That's the second type, just functions. Its name called a function. So we separate procedure and a function. We just look at the output, if it generates some output or not. Yeah. Return data. Okay. Yeah. All right. Yeah. The properties stored and executed by DBMS at the database server. Stored. Yeah. It is stored because we need to use SQL statements to define procedures and a function. SQL statements. Okay. Stored here, stored as metadata, right? Yeah. Last time we learned this concept, metadata. It's not original data. It's not the business data. So it's the metadata that stored the procedure. Also belong to that. Okay. Yeah. Executed. Yeah. Executed by DBMS at the database server. Yeah. Because it's part of your database definition. Yeah. So this part, okay, part of the database definition. So that's the reason when you execute it, you need to run it at the same DBMS database server. Okay, yeah. All right. Create it in DBMS or in application programs. Here, yeah. We understand that easily. We just run SQL statements. So we can create this procedure or this function, or another important way to create in application programs. Not necessary in that DBMS database server, not too restrictive, right? You have to think about there are so many different locations, right? Your database server just one of the servers in the world, right? If when you need to create a procedure, you need to do in that particular server, it's not convenient, right? So we want to create remotely. How about that? So here, this corresponds to create it remotely, not locally. Yeah. Because the physical location could be far away, not in the city, could be in different country, right? The travel expense, so expensive, right? We just want to create locally right here, so convenient. You know, yeah, the cost is very low, right? Yeah, we just write our application programs. Yeah. Because our application programs allow us to run SQL statements. We can run SQL statements inside our application programs. When we run, we generate that procedure. Any procedure we like to create, we can generate. Think about that. Convenience. Okay? Yeah. All right. Another property that, yeah. Called in application programs, definitely in DBMS you can call, okay? DBMS as well. No problem, yeah, because that's the, natural way. Yeah. But other than that, we can call remotely. So this is called locally, right? This is called locally. An application program, this we call remotely. Okay. All right, because when you create procedure functions, you need to give them names, right? You need to give them names, function name, procedure names. You need to give them names. But when you call, that's very easy. Call procedure here, let's see, name. Yeah. No. Yeah. Just in that way. Call that name. You execute that function inside DBMS. So simple. So simple. Yeah. Okay. All right. Next, circumstances using store procedures. Yeah. So here, let me describe that efficient way, right? In the previous slide. Yeah. Here, let me expand that efficient way. How do we use these stored procedures efficiently? All right. Typical cases in usage. So when we use these stored procedures, the typical cases. All right. All right. A database program is needed for several applications. Yeah. Here, although think about it, in one web application, we create some store procedure, but this store procedure is not limited to that particular web application. Many other web applications can use that procedure because that is just a SQL data processing process, one whole process. Yeah. Then it is available for many other web applications. Okay, yeah. the applications could use different programming languages. Think about that. Different programming languages, not just the one language. Here you will see, due to some business reasons, people may use different programming languages for the same system. Think about that. One system, the same system. Yeah. Here, let me draw diagram, similar diagram another time. Okay. Yeah. Multiple servers. All right. Yeah. S1, S2, S3. All right. Yeah. S1, think about, we use Java in S1. Server 2, we use PHP in server 2. Server 3, we use C# in server 3. Due to some reasons, people may use different programming languages for different parts of your web application. That could happen. Yeah. All right. So under that situation, here I talk about, yeah. All right. When we write our critical data processing algorithms, here we are talking about running critical data processing algorithm. Okay, yeah, here we're talking about this issue, all right? Yeah, okay. So you need to write programs, right? Yeah. This point, reduce duplication effort. What's that? Duplication effort. All right, here I explain this way. We can use, so here, let's say these possible ways we can use to do these critical business tasks, critical business. We can use SQL to run our algorithm, right? To implement our algorithm. We can use Java to implement our algorithms, right? We can use PHP to implement our algorithms, right? We can use C# to implement our algorithms, right? Now, think about that. If we use SQL to implement, yeah, SQL to implement, we only implement once. We only implement once. Yeah, because other programming language we just call SQL, all right? Call SQL. How about that? Okay. Reduce duplicate effort, duplication of effort. Yeah. Yeah. That algorithm, we do not need to write our code, we just call SQL algorithms. Okay. Yeah. But if you do not use SQL, write a SQL procedure, you need to write a Java program, Java algorithms, right? Yeah. Then at the PHP side, you cannot run Java programs, right? PHP side, you need to write your PHP code for the same algorithms, right? When you go to C#, you cannot use PHP version, you cannot use Java version. You have to, write a C# code. That's the duplication of effort. All right? SQL, one version, everybody calls that. It's good if you update that SQL code. All other people, all other servers, they just get updates immediately. Yeah. So here you can see the advantage. Okay. All right. Improve software modularity. Module, so that module, that data processing SQL procedures we treat as one module. Yeah. So then the other web programming code in different programming languages, you can treat as different modules. Okay, so the different modules, they can work together. Yeah. Module 1 call module 2, module 2 call module 3, right? Yeah, work together. So even they are in different, think about it, even they are in different programming language, you can do communications. Yeah, because different programming, you need to do communications, right? How do you do communications among web components with using different programming languages? Okay, they need to use the same standard. Think about same standard, right? Because communication, you're sending data, right? What do you mean communication? Sending data. Okay, so here the most popular way, sending data communication. Most popular data format for communication JSON. JavaScript object JSON. Yeah, so I will talk about that. It's pretty simple. It is very simple. Yeah. Yeah. But very useful. Otherwise, how can you do data communication between different programming languages? Okay. Yeah. So your data format should be neutral to programming languages. Okay. Yeah. So, all right. Reduce data transfer and communication cost. I explained this point before. Yeah. Yeah. I explained it, reduce data transfer, because remember that intermediate data, we do not need to send intermediate data, right? We only need to send the result data. Yeah. Do not send intermediate data. Yeah. Only send the result. Because that module here, we talk about that module, the whole module generate that result. Generate this result. Yeah. Intermediate data all manipulated in the same location. No data transfer needed. Right? Yeah. Okay. Yeah. Access data without giving out too much permission. Yeah. This is another point. Last time I didn't talk about it. So this time there is another reason we have an advantage using stored procedure. Access data without giving out too much permission. Why? Let me explain it. Yeah. Some users may not have access to certain tables. Yeah. Some tables, we may need to store some, secret information. The business, for the business, that part of data should be hidden from general users. Only people at a high level, they can access that important data. Okay? Yeah. That's normal. Yeah. When that happens, you cannot expose the whole table to the general users. Yeah. But in order to run the business, you need to provide certain information for those hidden, for those protected tables. Let's call those protected tables. Yeah. These users may need some aggregate information. Yeah. You are fine to provide aggregate information from those protected tables to the general users. The aggregate information, how many items for some purpose And what is the total? What is the sum? What is the average? What is the maximum? What is the minimum? That aggregate information, that you do not expose the sensitive information in the table. You just expose the aggregate information from the protected tables. Then you can create stored procedures to do that. So another reason you can use stored procedures. Yeah. Because people just call procedure. It returns aggregate information. That's it. Okay. Yeah. All right. Yeah. So here you can see. Yeah. The last one I like to show you how to declare store procedures. Pretty straightforward. Just like we store a function. All right. General form of declaring stored procedures. SQL. Yeah. Create procedure. Then procedure name, parentheses, parameters, local declarations, procedure body. Yeah. SQL statements as the procedure body. Okay. Yeah. Yeah. For declaring a function, you need to provide a return type. Yeah. Structure similar to the above procedure, but you need a return type. Yeah. Create function, function name, parameters. Then you have this return type. Then local declarations, function body. Yeah. That's the structure. Yeah. Today I will not give you examples. When I give you our main database for this class, and after we get familiar with our database, then my example just use our database, our main database. So then you can understand the meaning. Otherwise, if I give you example here, because you are not familiar with our main database, so you cannot understand the code. All right. Yeah. Then I have a few minutes because I have one slide left from module 1, part of C. So I want to finish that slide because there is some basic, simple information I like to talk about. Yeah. So let me, part B of module 1, basic steps for development. Yeah. Let me go through the basic steps for web development. Yeah. First, we need to start Apache server. Okay, yeah. Exam. Yeah. Yeah. Here, I give you plenty of time to install exam and, and you play around, get familiar with the environment. Yeah. Start exam control panel. Yeah. You click the start button. You start Apache, and click the start button. Yeah. For the MySQL, when Apache start, look at the ports. This 80 port numbers. That 443. For another internal purpose, but this 80 port number, it's a special port number. So we call it default HTTP port number. HTTP by default, we use 80 as the port number. Yeah. What's that? Because when you use this default port number to access one web server, you do not need to write it. You do not need to type 80. Okay? Yeah. So, for example, when we access our Apache http://localhost, we use port 80. Usually, we should attach that 80 port number after colon of the host name, colon port number, but this is a default port number. So we can omit that default port number. just localhost, then that port 80 will be accessed. Yeah. You can change the port number because sometimes for some students on their machine, port 80 is already used by some other software tool. That's possible. So you cannot access it anymore. Only one service can run on each port number. So you have to change your port number. In that situation, then you just click this configure button. The configuration file is opened up. Then you go to the port number, that line, that you can find one line, list the port number. You change from 80 to a different number. 90, for example, just to a different port number. Then you save. The next time, suppose you use 90, next time your local host, you need to, because this 90 is not a default number, you have to type it, :90, non-default. You have to explicitly type it. If 80 is already occupied by some other service. Okay, yeah, all right. Start MySQL if necessary. At the beginning, when we practice PHP, we do not need to start MySQL. Just practice some basic PHP features. Yeah. Later, when we need to access databases, we need to start MySQL. So, okay, all right. Then start IDE for PHP. Now, here we use NetBeans. Yeah. All right. After that, we develop a PHP project. So we create PHP project inside NetBeans and make sure your project connects to Apache server correctly. Yeah. Remember I mentioned that document root. I mentioned that htdocs, the concept, document root in Apache. Your project should be inside htdocs, the document, that folder, inside this folder, because that's the place for Apache to give outside people to access the documents in the server. Yeah. All right. Yeah. What's that? Yeah, I hide it. What's? Yeah, files structure. Right. Okay. Yeah, that's not that important. Yeah, that's because when we develop project, we need to use folders and file structures. Yeah. So I do not erase this. Okay. Yeah. All right. Run the PHP project in a web browser. At the end, after at some point you want to test your project, you need to run the project. Okay. Yeah. So right-click the project node and select run. Yeah. Then your default web browser is brought up, but the first time when you run this way, the default browser is very likely the Windows browser. Yeah, the first time when I run it, the default, the Windows Edge, that browser. So usually I do not use Edge. So I use Chrome. So then you need to set your default browser to Chrome. Yeah, in NetBeans, there is a place you may need to change your web browser. Yeah. At one place, you can set your default browser to Chrome and save your setting. Yeah. Then later, after that, when you run your project, you'll always call Chrome to run your project. Yeah. Okay. Yeah. In my videos, yeah, I may show you that setting part. Yeah, very simple. Very simple. Just find the right place, click it, select it. Okay. All right. Yeah, let me stop right here.